be presenting our work on From Motion to Behavior, physics-inspired hierarchical control of humanoid generative behaviors. Let's start by examining the current limitations in the field. As shown in these examples, A, B, and C, existing approaches focus primarily on low-level motions without considering high-level planning for long-term generation. This creates a significant gap in generating coherent, purposeful behaviors. Our work makes two core contributions to address these limitations. First, we introduced GBC100K, a large-scale multimodal dataset featuring individual human behaviors with multi-level textual annotations. Second, we propose PHYLOMAN, physics-informed generative modeling of long-horizon planning for hierarchical humanoid behavior, a hierarchical framework that uniquely combines LLM-driven planning with physics-based motion control. Let me highlight the key features of our GBC100K dataset. It implements hierarchical annotations combining behavior script, motion script, and pose script. Provides fine-grained motion descriptions using GPT-4o. Contains long-term motion sequences averaging about 51 seconds in length. As illustrated in the diagram, our data collection pipeline follows an internet-scale approach. The process begins with video collection from the internet, followed by processing through vision language large models, VLLMs, and pose estimation systems. This produces the final GBC 100K dataset, which is an effective step forward in creating rich, multimodal data resources for studying human motion and behavior. As you can see in these examples in our dataset, each behavior is carefully annotated with structured descriptions covering the subject, emotional state, action, goal, and environmental context. Here, only the subject and action components are mandatory elements. Here's a detailed example of our hierarchical annotation structure. First, we have the high-level behavior script describing the overall action. Then we break this down into detailed pose scripts capturing specific poses. Finally, motion scripts describe the transitions between poses. This hierarchical annotation schema enables more precise and controllable motion description. We also introduced PHYLOMAN, which features a training-free, migration-friendly inference pipeline, parallel generation capability for efficient scaling to longer motions, task and motion planning, TAMP, that uses LLMs to decompose and plan behaviors. The framework processes inputs through several stages. LLM planning, input behavior script, and output a composition of motion scripts and pose scripts. Pose generation. Generate SMPL poses as keyframes. Motion generation. Synthesize intermediate motion sequences between keyframes to produce a long-term human motion. And finally, physical refinement through our controller ensures physical plausibility of the generated motions. Finally, let's look at our results. We can see two versions. The top sequence shows motions directly generated from our motion generator. The bottom sequence demonstrates the same motions refined by our RL controller, showing improved physical plausibility and natural movement.